Recording started. Welcome back. So today we will discuss about application load balancer and network load balancer. In the last class, we just discussed about what is classic load balancer. So basically, classic load balancer is a load balancer which will distribute the traffic to the available devices which are attached to it. So end user will not have any access to our EC2 instances directly. So instead, we use something called as load balancer. So a load balancer will be hit by our end users, maybe Balram, Naveen, Ramesh, Spurti, Prithvi, whoever. So they'll be hitting a common URL. So let's say here we have received 5 requests. All the 5 requests will be received by a load balancer. In our case, we are talking about classic load balancer. So classic load balancer just receives the incoming traffic and it just distributes the request. It does route that particular request to the available instances equally. Right? So that's the reason. There is a little drawback of using this classic load balancer because I can't route a traffic on a condition basis or based on some content wise. So this is not possible in classic load balancer. So let's try to look at a few more load balancers and we'll see how they are helping us, to improve our routing of traffic as well as how exactly it is improving uh, kind of efficiency while routing the traffic to the available instance. All right. Now we'll talk about application load balancer. Okay. Whenever see the classic load balancer, whenever we have a situation of routing the traffic, and distribute the traffic uniformly, we'll go with the classic load balancer. When it comes to application load balancer, whenever you have a requirement of HTTP or HTTPS, right? What is HTTP? HTTP, it's a protocol which will be served with the port 80, right? And HTTP is a secure HTTP protocol, so which can be run through 443, right? So if your applications are running over the port 80 or 443, then it is recommended to use application load balancer. So this will be the interview question, right? So so definitely people will ask when do you go for application load balancer and when do you go for network load balancer? If your applications are web applications which are running on some web server and you need to implement a load balancer for these applications, the applications which are running on port 80 or which is using a protocol called HTTP or it might be using a protocol called HTTPS over the port 443. If this is your requirement, you should go and implement application load balancer. See, in your organization, being a solution architect, customers will be asking you to select the appropriate load balancer for one of your requirements. And if your requirement is to enable or if you are receiving the traffic over the port 80 or 443, blindly you go ahead and select or you suggest your customer to go ahead with application load balancer. Okay. Now let us try to implement application load balancer. But see, for the classic load balancer, what we did, we just created an instance, and after creation of the instance, we created a load balancer, and we attached the instances on the classic load balancer, and we started seeing the routing of traffic to those two instances. Correct? So in our case, it is not straightforward. In application load balancer, we have certain slightly different steps. If you follow them, we'll be able to achieve. We can create our application load balancer. Let me draw a diagram. Let us understand how it works. So definitely, we need a couple of devices. In our case, let us try to create two EC2 instances. Okay, and first instance I will call this as web server one, and
Ah,
the
you are
second.
Your screen is not visible actually.
Oh my God, till now, whatever. Oh,
Yeah, yeah.
I'm sorry. I thought I've shared, and I did a lot of things in the background. Oops, that's okay. So let me recap. So if your applications are running over the port 80 or 443, so then you are supposed to use application load balancer. So definitely, people will definitely ask when do we use application load balancer compared to a network load balancer. So if your applications are running over the port 80 and 443, or which are running through a protocol called HTTP or HTTPS, so it's our choice to use application load balancer. Now let's have let me try to draw a diagram and let's understand how it works. So this is the web server 1 and this is the web server 2. So in web server 1, I'll have one implementation, and web server 2, I'll have another implementation. For example, here I'll say google.com or Google page, or something like Google image, or in the web server 2 is kind of a custom image, custom images in the sense which I will be customizing, and I'll be selecting some of the images, and I'll try to upload it on this server. Okay, so each server are defined or created for different purpose. The web server 1 defines a Google image, web server 2 defines a custom images. All right, now we need to have a load balance as usual, correct? So let us create a load balancer. So in our case, this is a application load balancer. Okay. Now, as of in classic load balancer, so for example, see, if we consider classic load balancer, directly we used to know this load balancer is to communicate with these two instances which we have attached, and also it is to take care of the checking the health status of these two servers. So if something goes wrong with this server, then it starts routing the traffic to the active server which are healthy in state, right? So this is how we used to do. When it comes to application load balancer will not have direct contact with the instances. Please understand this one. So our application load balancer, or going forward, we will be learning a network load balancer. These two load balancers, they don't have access to these servers directly. Instead, what exactly it does are it does look for something called as target group, something called as target. So we can attach, or we can implement, or we can create multiple instances, and we can attach to one target group. That is also possible, right? Please understand, we can create multiple web servers, and we can attach to a single target group. So when load balancer hits a request, when customer hits a request to load balancer, then load balancer will hit a target group one. We will say how exactly it routes the request to target group one and target group two or three, whatever. Right? For example, if user is trying to access something from this load balancer, when he hits the load balancer, this request will come to target group one. This target group will have necessary information to call this particular web server. Similarly, let me create another target group called target group two. So this target group will have necessary information to communicate with this web server too. So target group will take care of the health check, checking the health and the status and everything. So this will be taken care by target group from the instead of checking from the load balancers directly. Why do we have these conditions? Why do we need a target group? So basically, within the target group, we can define some rules. So, so see, we are just introducing another mediator from the between load balancer and the EC2 instances. So the main advantages of having this interface that we can customize our request. We can customize our request, which means we, we are not blindly routing the traffic to available servers. Instead, I can just I can restrict my request to get into a particular page. What I mean to say, for example, no, if you just type google.com, so we are ending up by getting one page. Instead, if you just type Google Drive, we'll get another page, right? And if we just give something like Gmail, we'll get another page. So which means these are all the conditionally we can route a traffic to a particular server. We can route a traffic to a particular server. So this is how it works, right? So that is what we are going to achieve. So what we will do in order to do this, we'll create two servers, right? And within the within web server one, we'll create something called as index.html. Let us implement this one first, okay? So let us implement this one, and later we'll customize. We'll try to implement some other things as well, right? Okay. Now, as part of this, so let me log into my AWS console. So log into my account as well. What is the steps? First, okay, we'll just try to define some steps to be followed, so that will be easier. So first, we'll create two EC2 instances, and we'll install. We'll create our web page. This is done. What is the second step we need to do? So we are not creating directly a application load balancer. Instead, we are creating a target group. Create target group 1 and target group 2. And after creating the target group, I should attach the instances which are associated to a target group. Okay. So we are creating the target groups and attaching the respective web server. So because I can't call this as EC2 instance, because now we have already installed a Apache Tomcat on it, so I can call this as a web server. This is done. Afterwards, I need to create a application load balancer. Okay, so we'll create the application load balancer, and what do we need to do here? We need to attach target group to our load balancer, or application load balancer (ALB). You see my point? First, we'll create our instances and we'll make them as a web server, and later we'll create a target group. Then we'll attach the corresponding instances to the target group, and the same target group will be attached to a load balancer. So this is how the relationship between application load balancer and target group and EC2 instances. Right? We'll do that, and let's see how it works. And afterwards, I will come back to the same diagram and we'll try to customize as well. Right? All right. So yeah, this is my account. So let me create two instances. So for now, let me say help of boot scripts. Okay, so let me click on instances and let me click on launch instances. Okay, I'll just call this as web server 1. Now, what's the next step? Let me select the Amazon Linux only for now. And yeah, instance type, I'm selecting T2.micro, which is giving me one virtual CPU and 1 gigabyte of memory. And as I'm in North Virginia region, so I'm selecting a key of North Virginia, which I have created earlier. And later I'm creating a security group. So in order to create a security group, either you can go ahead and select the existing security group as well, So I remember launch wizard 16 will give me enough information. Yes, as this is a web server, I need to do SSH to this machine, and also I'm accepting the traffic via port 80 with the help of protocol HTTP. Now I'm good. So launch wizard 60 is giving me the enough port details. I'm just selecting that instead of creating a new one. And I'm fine with the volumes and everything. Now let me add a bootstrap script. So what exactly it does, which will help me so that I don't have to manually install Apache Tomcat. So in the first machine, R will say routing the traffic to machine one. Okay. So let me try to give this text and let me click on insert. Okay, it has got created. So now let me create another instance called web server 2. So I'll just follow the same procedure. I'll just select the Amazon Linux AMI only. By default, it is selected, and I'm going with G2.micro with one virtual CPU and 1 GB of RAM, and I'm selecting a key pair, and let me select the same security group which has selected here. So what is that? Launch wizard 16, and which will have the port details of 22 and 80. Next, okay, let me get into advanced details. Here, let me try to customize it. So routing the traffic to market. So let me click on instance. Now, by this point of time, my first web server should be up and running. So let me refresh and let me take a public IP of this and let me take it in a browser. Now I should be able to see my customized website called routing the traffic to a Linux machine 1. All right. Now let us try to verify on the second instance as well. Let us check if it is in running condition. Now still it is saying pending. Yeah, now it has come to running state. Now this is my second. I think it's running state. Yeah, you can see routing the traffic to Linux machine 2, right? And this is sending a traffic to 1, right? Okay. Now this part is done. So we have created two instances. We have installed Apache Tomcat on it, and also we customized it. Now, what is our next step? We need to create something called as target group. What exactly target group? Target group will kind of interface which resides between application load balancer and the web server. Why do we need a target group? Because we can write some conditions or we can customize our request so that we can route this particular traffic to or we can say we can route a dedicated traffic to a particular machines which are available in this group. Why are we calling this as a target group? Because this target group will have a target machine. So that's the reason we call this as a target group. Okay, so target group will have the corresponding machines which are attached to it. So which means which will have a target machines. The collection of target machines are called as target group. Okay. Now, so let me try to create a target group. So let me click on see on the EC2 wizard. You can see come little down. You can see option called target groups. So as of now, I don't have any target group. Let me click on target create target group. He can go via IP addresses or instances or Lambda functions, and even you can go ahead with the application load balancer. Probably when we create a network load balancer, we'll try to select this application load balancer. Let us keep the things very simple. So I'm just selecting the instance because we have created two instances, right? Now,
బలరామన్నయ్య ప్రభు కాడే కదా ఇది
Naveen, you got mute actually.
You are on mute, Naveen.
okay, I'm audible now.
Yes.
Thank you. So I'm just creating a target group. So I've given a name as a target group 1. So if your application is running on the port 80, and if you are using a protocol called HTTP, you should go ahead with this configuration. If you are communicating via secured HTTP, then you should select that one. So as of now, we don't have any certifications as such. So we are using HTTP request. So we are just selecting the default.
I mean, what if you want to add more than one protocol?
We will do that. I mean, you need to create another target group. We will see that.
Okay.
Then let me go with the default VPC and health check. If you want to give some path, you can give. Just leave it as it is. Let me click on send. What I was saying, once we create a target group, we should attach instances to this particular target group so that these instances get registered under target group so that application load balancer can directly communicate to a target group. Then target group intent will communicate to our instances, right? So the second part will be we have created a target group and we are trying to attach the respective web servers. So for now, let me attach a web server 1 to the target group 1. And let me click on include as pending. Okay, now just create a target group. Creation of one target group is done. Now let me create another one. So I'm just selecting the instances. If you want additional one, you can create. If your application is listening to some other port, definitely you can enter those details as well. So let me try to give a name as target group 2, and yeah, let me click on next. And let me select. See, you can, as I mentioned, we can select multiple instances for our practice purpose. I'm just created each instances for each target group, and now I'm able to create 2 target groups, and each target group will have necessary web servers attached to it. Now, see the load balancer, what exactly it is saying. It is not yet associated with the load balancer because we just created a target group. So this part is done. So we created an instance, and afterwards we installed some necessary softwares on it, and we did customize our website, and later we created a target group, and we have attached this machine to this particular target group. So this part is done, and as we have 2 machines, this part is done. So completely we can say this implementation is done. Now we will have to create a application load balancer, and we should attach these 2 target groups to this particular load balancer. Then our job is done. Now In order to create a load balancer, just in the EC2 wizard, come little down on the section of load balancing. You select the option of load balancer. Click on create load balancer, and our intention is to create a application load balancer. You can see here and click on create. Now give a valid name. For now, I'll say application load balancer. I'll just say ALB. In our technical terms, going forward, even in your organization, so we'll not completely define it as load balancer or application load balancer. We'll just if it is application load balancer, we'll just term it as ALB. If it is network load balancer, we term it as NLB. Okay. So by considering that, I'm just giving the name as ALB-1. And as I mentioned, it is internet facing, which means everybody in the world, they should be able to access this URL, whatever the load balancer DNS name which we are getting, all should be able to access it. If something needs to be restricted, then I should go ahead and select the internal load balancer. My purpose is to access by everyone. I'm selecting internet facing. IPv4, IPv6, we'll discuss when we discuss about VPC and other things probably in upcoming sessions. So now, okay, these are all availability zones which I'm supposed to select. Why do we need these selection of availability zones? In real time, whatever we create our instances, so we should be creating under any of the availability zone. Do you see my point? For example, this is under AZ1 and probably this will be under AZ2. Why do we create like that? In order to maintain, to achieve high availability for disaster recovery. So, in each availability zone, we used to create our instances. In our example, probably we have created. I'm not sure. Have selected any availability zones specific thing while creation of instance. Leave like that. We'll be discussing them, in future. So as of now, let's consider we have created our instances in one availability zone of North Virginia and the second availability zone of North Virginia. Right. So this is how we used to create our instances before attaching to our target group. Now, the reason we select all the availability zones, it is recommended. It is not mandatory. You can select the availability zone. You can select the availability zone where you have created an instance. If I have created an instance, for example, I have created both the instances under US East 1B, then it is sufficient to select only one availability zone. But it is recommended to select as many as availability zone because we are not sure. Probably if some requirement comes, I may spin up another EC2 instance and I'll make that as a web server and I can attach to this target group. Right? So it's all up to me where exactly I'll create my instances. So that's the reason it is always good practice to select maximum availability zone while creating your EC2, load balancer. Okay, I think I have selected all. That is good practice. And here I can select up to 5 security groups. So here we are maintaining the security group as of our EC2 instance. So I'm just selecting launch wizard 16 because yesterday we were talking, right? Whatever the requests which are coming into our application load balancer, the same protocol will be using to communicate to our EC2 instances. Right? So that's the reason we maintain a similar security group setup in load balancer as well as our instances or web servers. So okay, that thing I've selected. We will talk about listeners probably in some in another 20 to 30 minutes. For now, what exactly this listener will do? See, this listener will have authority to route the traffic to select the appropriate target group. Right? So, which means here we can write a condition based on some condition. For example, if request comes like custom, just route this traffic to target group 1, or we'll say okay, target group 1. So this target group 1 server will load the Google images. If some request comes like slash images, then I'll say that whenever you get a request by ending with slash images, just try to select target group 2 and route a particular request to appropriate web servers which are attached to this particular target group. So here, this is the part of listener. So this is something called as listener. So with the help of the listener, we can customize our traffic routing to a particular target group. Right? Okay. And for now, see what exactly this we have a listener called HTTP colon 80, and here we can select the respective target group. What exactly it is saying? So if some request is coming with the protocol HTTP with the port 80, let me forward this request to target group 1 or target group 2, whichever we select. Are you getting my point? So this is the listener part which I am explaining. So what exactly this listener will do? In listener, we can have some conditions to route the traffic to a particular target group. So the routing the traffic from application load balancer to target group will be taken care by listener. So here I'm just selecting target group 1. Okay. While creating a load balancer, it is good practice to select only one target group, and later we can attach the remaining target groups. Because if we just add another listener here, sorry, your protocol IP or the port number gets changed, right? But in my case, both the servers are listening to port 80. So that's the reason we will be selecting only one listener rule. We will be selecting only one listener rule while creating a load balancer. Okay, and afterwards we can just go with the summaries and click on create load balancer. So with this, we'll be able to create our application load balancer. Let us click on this load balancer part. Now, so it is in provisioning state, so it should come to active, then only we'll be able to access my domain. See, in the description, you can see certain options. In the description, see, this is the ARN. We will see what exactly ARN probably in the later sessions. Now, let us concentrate on the DNS. So this will be the DNS name which will be given to us, so that we are not directly communicating with the instances, or we are not directly communicating with the target groups. Instead, we are just making use of this DNS. We just copied it. What is A record? We will see that probably in our row 53. And status, it is saying it is provisioning, and see, the type is application load balancer. In our previous example, we created a classic load balancer. If that is the case, it will show here as classic. If you have created a network load balancer, it will show here as an application load balancer. And this is the instance facing. And availability zone details, whatever we have created, everything. I mean, whatever we have selected. So what exactly it says? With the help of these subnets, wherever you create an instance, I will be able to communicate with them with the help of target groups. Right. So this is how the communication works. So we'll wait for some time till it comes to active state. Meantime, let me go to listener part. Okay. Listener is nothing but here under listener, we are writing the rule and restricting my request. Hey, if you get a request with this port, then go here. Go to this target group one. Please understand. So if some request comes with the load balancer, then over the port 80, then we are routing that particular traffic to target group 1. Let me click on target group 1. What exactly we have? See, this is the target group one. Let me click here, and here you can see there is one web server which is attached here, right? And the health status still it is initial. Do you see my point? See, how did we come here? Don't get confused. So let me recall. So let me come to load balancer. So this is my load balancer. You should select your load balancer, and the status is still saying it is provision. That is okay. And under listener's part, you can see the traffic routing. How exactly we are routing a traffic to a particular instance. So if load balancer, if we hit a load balancer, then the first thing will happen. What will happen here? It is the request will forward to this target group. See, this is how we are mentioned here, right? If some requests are coming in, we are telling just go and hit this target group. Okay, let me get into a target group. So this is my target group. Right, I just click here. So this is the target group details which have selected, and here it is saying this is the target or registered target under the target group one, and you can register multiple. If you want another one also, you can click on instance, and you can click here and registered as pending below, something like that. It will come, and you can register multiple instances also. Now my instance status are healthy. You can see here. Now let me come to my load balancer, and let's see if it is still provision active. Now it is active. Now I'm good to go ahead and check the traffic details here. Okay. Now let me open a new tab and let me hit. Can somebody? Okay. Meantime, you can also check this one. Let me try to pin that in the chat box. It's all of you to check, verify if you are also able to access this. Okay, just please check. Okay, so now the purpose of creation of a load balancer is to distribute the traffic to multiple machines which are attached to it. But even I'm requesting multiple times, but still the requests are getting routed to the first machine only. Why? Can anyone tell?
Yes, Naveen, can I? Because the load balancer is attached with only one target group, and that target group is linked with only one web server, that is web server 1. And that
Exactly.
is the reason. Yeah.
Yes, good. So now we'll have to see. I cannot add one more listener. If I add one more listener, port on a port number definitely it gets changed because each listener should have a unique port number, right? So in these things we'll overcome in network load balancer, but still we can customize these listener parts. So my intention is, so as of now what we have done, this part is done. So this load balancer is attached to this particular target group, and target group is attached to this web server. So that's the reason whenever we are hitting our load application load balancer DNS URL, the traffic is getting to target group one, and which is in turn calling the web server one. So that's the reason we are able to see only this page. No, we can't route the traffic to another one. So in order to do that, I should edit the rule. Either you can click here and you can edit, or you can click on view or edit rules. Okay. Yes, we are supposed to edit the rules which we have made. Now there is option called edit rules. Click here. Okay. Now there is an option called edit rule. Click here. Right. Now there is an option called edit here as well. Click. See what is happening here? There is only one target group while creation of our application load balancer we have selected. So all the traffics are going to this target group. So hence the traffic distribution will be 100%. So that is the only reason you are keep on seeing the same website after hitting your DNS of load balancer. Now it is my responsibility to include another target group so that I can distribute the traffic. So I'm trying to attach this part. I'm trying to attach a target group 2 to the load balancer so that this machine also will be functioning to receive the traffic from the load balancer. Okay, so now just click here, select the target groups. See, no, you can't see this option. So here, because this target group 1 which is already selected. Now see here again, if you just save it, again you will not get any traffic because you are saying 100% of the traffic should get into this particular target group. And if you just give here also 1, then traffic distribution, we are just dividing the traffic distribution across two target group. If you give 3 accordingly, this is the conditional base, right? See, previously classic load balancer, it does distribute the traffic uniformly. If you have 2 instances, 50% of the traffic should go to one machine and 50% of the traffic should go to another machine. But here I can customize my requirements. So if I say, let's say the instance which we are creating under target group will have higher configuration compared to target group 1. If that is the case, I'll just choose a target group 2 and I'll try to route the traffic more here. Or if some of your application hosted in target 1 are used rarely, if that is the case, I'll just route that. This is how we'll route the traffic. But now let me try to maintain the same so that for demo purpose it will be easy for me. And just click on OK and click on update. Now complete implementation is done. Now the request should be routed to both the target group. Each target group will take care of the routing the traffic to this particular machines. Now this is done. Let us try to. You can check now. Okay, it is now we are able to see the traffic is routing to the second server via target group 2. So just continuously this will be 1, 2, 1. This is about application load balancer. Okay, but we'll still try to customize. If you understood, I'll just go ahead and I'll still customize application load balancer. So this will be your real-time scenario. See this creation of your application load balancer and creation of a target group attaching to these instances, fine. But from now, whatever we are going to discuss, again we are customizing our application load balancer, which means again we are customizing our traffic to route to a particular machine based on some vector. Okay, we'll do that. Now, what I'll do, let us think of one scenario. Okay. So, this web server has a index.html. Web server 2 also have the same. Right now, let me create another application within web server 1. Please understand, as a 5th step, what I'm trying to do here. Create what's it? Google Images. Okay. Google Image application on web server 1. Okay. And the 6th point, create custom image application on web server 2. What do you mean by this? Within this server, As of now, I have only one application that is that is maintained by index.html. Where exactly this index.html will decide under var www and html, and within which I will try to have another application so that multiple applications can be implemented under one server. So that, and we can route the traffic as per my request. We'll customize. We will see that. You all are you able to follow me? See, uh, this is the application load balancer implementation part. Now we are trying to customize our request further. In order to do that, let me try to implement two more applications. So on the web server one, let me try to create something else, and on the web server two, we'll try to implement something else. So that let us try to get that request as well. So that is it. Okay. Now, in order to do that, I should get into my EC2 instances. Let it be like this. So let me open a now click on the instances which are running. Now let me log into the web server one. So how to do that? Let me click on putty, and this is in North Virginia region. So let me set the key of it. Accept the cert. The default username will be EC2-user. Now this is done. Let me log in as a root user, where exactly my implementation is there. www.html, and this is how correct, right? So with the this is what our application. I mean, this is where I have written my code to print, routing the traffic to Linux machine one here, and in another instance we have on the same path. Now, let me try to create another directory. So in my case, this directory refers to another application. So what was the name we have given here? So let us try to make the same Google image, right? So okay. Google image. Now afterwards, I should get into this folder. So cd space Google image. Now let me implement something. So how to implement that? Just creating the HTML page. See, I'm just making it as simple. If you are a developer, if you have some development background, you can create a very good website or whatever the logic you want to put. You can put it there. And so I'm just using VI editor so that I'll be able to edit the content of this index.html. So in order to insert, I should press I. Now you can see this has come to insert mode. So this is the customized page, and it only contains Google images. I'm just pressing escape so that I'll just come out of the insert mode and pressing colon, and I'm pressing W, which means I'm writing the content to this file, and I would like to come out after I write. Enter. If you just cat, you'll be able to see. Yes. Now, how to access this one, right? Via this Google image, right? Now, let me come to first your instance, right? This is your first instance, right? See, this is the first instance, second instance, and this is the load balance, correct? Now, on the first instance, if I just type it here, I'll be able to see the routing the traffic to the Linux machine one / if I just give Google image, even I'll be able to see the customized page. Is that okay? So similarly, we'll write a condition in load balancer so that if I just hit this request with Google image, I'll be able to see the same page, right? Okay. So now let me log into web server 2. So that we'll also create some applications there.